Thank you, everybody. Wait for a presentation to come up, or do I need to advance it? Okay. So I'm going to also talk about a pilot that we did with Google and the ELS, one of the other providers, on doing the services. And a little bit about it. So we wanted to look at what we were doing on how this fits in, really is going along with the carrier's location information. So our view of this is not so much putting it as a supplemental or a separate location on the screen to allow the call taker, telecommunicator, to pick which one to use. We're looking at it as combining it in with the carrier's location, on working with a wireless carrier, and including this as the main alley and the main location in either an alley feed for traditional PSAPs that we have today, or it could also be in for next-gen PSAP, working in either way. The solution that we had on what we were looking at doing is it must integrate into the existing PSAPs. There can't be changes to the PSAPs as we work on that on legacy. We saw how long that took when we did wireless phase 1 and phase 2 on trying that to deploy in the country as we're doing it. So we really wanted to look at solutions that would integrate onto the existing PSAPs and not require new training issues or new technology to go in. But fully, we wanted to make sure it fully supports next generation networks too. And next generation network is great because with ELS and technologies like this, which I really consider like a device-initiated location for 911, the technologies are much faster on how they're pushing this location through. So having a next-gen network where either it can be a subscribe type notify method where the locations are pushed down to it, or they can query more often, we're able to get the locations in much faster. So it works much better with the next generation networks. And the really thing is at the end, we wanted this location to be a single location passed down to the PSAP over the existing location. So if it's a better location than what the carrier is doing, and we can validate that it is a better location and that there's not a problem with it where it may be off, we're using information that we have from the carrier's network to make sure it's a valid call, that there's issues that it may not have been spoofed or other things, validate that it becomes a subset of what the carriers are already doing, and then compare between those and pass the single location down to the PSAP. We did in 2 pilot locations. We did in Snohomish County, Washington, which has a population of about 704,000 people. And we also did it in Palm Beach County, Florida, population of about 1.4 million people. In this mode, we did it with live 911 calls, but we did not want to interject it for a confusing point to the telecommunicators at that time. What we did is we took all the data that we have of when the calls came into the PSAP, what location was done, when the wireless location was available by the wireless carriers, whether or not that location was bid, looking at all the information and saying what would it have done if it was delivered to the PSAP? When would it come up? What location would have been used? And which would have been a more accurate location at that time? We also did it, we normalized it. If we look at normally the ELS data comes with a confidence of 68%. In 911, we use confidence of 90%. So there's a difference of what uncertainties and what numbers matter. So we normalized all this so it came up in the same numbers that we're working at the PSAPs are used to seeing of a confidence of 90% of all the numbers. So as I look at it, and this was sort of mentioned earlier on some of the other presentations, it's really where's the value of a location when it comes in? And I often say really a real value if we don't get the location when the call is answered at the PSAP, because the first thing they ask is what's the location of your emergency? Majority of that value of that location is lost if it's not delivered with the call. So we really look at how will it be? And on average, we're seeing about 10 seconds from the time the call is presented to our server by the wireless carriers, saying a 911 call is being placed, to the bid comes in from a PSAP is on typical 9 to 10 seconds, but depending on the technology. As we move to next gen, that time's can get smaller and smaller. So getting a quicker, so we'll actually see less and less of traditional locations as we see today being presented with the initial call as we move to next gen. One of the pros and the cons, it's quicker, but we're not going to see the location as quick. And then later on, we need more accurate location, but it's much further into the call itself. So what we did is the solution. One of the things was talked about was a challenge I think that even the Google team kind of talked about with ELS is how's it integrate into the wireless carriers network. We look at this as we implemented into the wireless carriers network in a fully standards compliant approach. We made the server, this ELS server that the data is being sent from the phone to the server, fit into the network very much like the existing location servers are to a wireless carrier. So today they're querying a PDE or an ESMLC, their location server, and it's coming out of a node called the Mobile Positioning Center or a GMLC, the gray box that's there, the blue box is connecting to. And what we're having it do is basically it's querying in another box on the same protocol. So it's saying I'm getting 2 locations. It's already set up to be able to handle this. So it fits into the wireless carrier's network as really a fully standards type compliant solution for the wireless carrier. So it's very easy to implement. And what it does is, so our server right there really is the WDLS. It's the extra server that connects there that's receiving these messages from Google, ELS, and we look at other location sources too. And we're looking at multiple location sources that maybe come in, where ELS, it becomes one of the many components that we'll be utilizing to sort of augment the locations for the wireless carrier. So talked about the accuracy. Those are the results of the pilot. You're going to see similar results for all the ELS type data because it's the same ELS data. So what I'm going to look at first of all is sort of where the uncertainty is. And so that was one of the things to remember is these numbers of uncertainties may look a little different than some of the others because we've normalized these to the 90% confidence. So the GPS uncertainties look really good. The Wi-Fi uncertainties also look really good on what I'd call a phase 2 capable location. Remember, uncertainty measures sort of the quality of the location, what we think it is. It doesn't actually relate one-to-one to accuracy. The accuracy, we need to go out there and do ground truth. It says, we believe with a 90% probability that we think that the call is somewhere within that area of uncertainty. Not that it's right in the center, not that it's right at the edge, but it's somewhere in there. It doesn't say how accurate it really is on what the carriers will measure. An important thing to always remember on that. So one of the things we really looked at is what are the locations we're getting today from the carriers, the phase 2 locations, what are we getting on the first bid, and what are we getting when the PDE really was only providing a cell ID location. So what we see for the carriers today, some other numbers, on the initial bid, when the call was answered at the PSAP, we were seeing in our trials about 20% of the times the call was coming in with a phase 2 location. And the other 80% it was not. When we added ELS to the mix to it, we were seeing that ELS was giving us about 58% of the time we were getting a phase 2 capable location in that exact same time window of when the bid came in, when the PSAP answered the call. And we were using that, we were actually comparing the actual timers when they came in to see if it was available. If we look at the phase 2 location information and where it is, what we really found is when the carrier was only providing a cell ID location, ELS was also providing a location that would give us a pretty good location too. We found that 46% of the time when the carrier only had a cell ID location on the initial bid, we were getting a location from ELS. So that was saying in those times when you were only receiving phase 1 location at the PSAP, we would be getting phase 2 and then 46% of the times. The only reason we weren't getting higher is just an issue of timing, how quickly the location comes in and when the bid is coming in. If we look at later on in PSAP bids, and this is it kind of becomes interesting where it is, one of the things to remember is on a wireless carrier system, if we look at 30 seconds, we get a pretty good yield of phase 2 locations. It doesn't mean the PSAP has bid that, because the location information is really most useful at the first bid, but oftentimes we have the location that's come back from the carrier and it's sitting on the GMLC but hasn't been bid. And what we find in general across the carriers, if we do it between the different carriers, about 83% of the time, and we saw this in the trials, we were getting a phase 2 location eventually at the wireless carrier. It just took longer to be done. We were seeing with the ELS, the yield, if we add in the GPS and the Wi-Fi, it raised it up significantly. We're getting a 90% yield of location, of getting a phase 2 capable location at sort of a later time point. We took this very conservative. We said we only wanted to look at the first location that came back from either the carrier or ELS on this. So if we look at also, we want to say, what is the potential of making this more accurate as you look at the call later on down the line? How does ELS improve overall accuracy with the carrier that you may get at this later part? So we looked at this point of uncertainty, reported uncertainty, because you might use uncertainty to pick which one is the better location of where it is. And what we found is that about 15% of the time, the ELS was slightly better location than what the carrier had. Other percent of the time, the carrier's location was good enough of where it was. But then we also found that 19% of the time, the location was significantly better, where the carrier's uncertainty may have been reported at, maybe it would be 200 meters, but the ELS uncertainty would be reported at 10 meters of uncertainty or so on. So we found altogether about 34% of the time we were getting at the final location, we were getting a more accurate location with this because the mix of what we were getting with Wi-Fi and also some of the GPS locations are a little bit more accurate also. So really, when we look at this, as sort of the conclusion we found, the ELS really was significant on adding more accuracy, making the location information more accurate as it was delivered to the PSAP. And it was done, it provided in a very simple way. It was ELS for us was very easy to connect up to and pass it. There's still some work to be done with it. There's ways we'd like to get the percentage of the calls that we get, the Android devices that pass ELS to be improved. We think it can improve the information the location even further. We think we can improve the speed of it a little further. It's a fantastic starting point we have that really improves it for the carrier. We think the best way of delivering this is through the carrier's location network, where it becomes a piece of their location infrastructure that they choose and validate the location information and pass that on to the on down to the PSAPs. Thank you very much. Any questions? Yes.
So, as a 911 center, when might one see this in production, where it's actually being delivered into a PSAP? Given that it seems to be working, what are the roadblocks to turning it on into 911 centers?
Biggest roadblocks right now are going through the evaluation and testing with the wireless carriers. We test this very thoroughly. We want to make sure that it doesn't cause any problems or cause any impacts. So we're going out there testing it. We're going through proof of concepts or pilots or trials with major carriers right now. The WDLS, our base platform that we use, that's a node that's in production, that we have in production right now. The plugins and how we do it, the major time on taking it is just evaluating it into the carrier's network and then turning it on. The nice part is once we turned it on with the carriers, it's not anything that have to be done at the PSAP side.
So will we see it in 2018 or 2022? When will we see it?
I hope so. Yeah. So, I mean, my intentions are, I mean, our WDLS platform is going live in 2018, so it's going to be there available. I'm not going to say I'm going to predict what the carriers do on where it is.
That make it available, but the
yeah, we're making it available. We're in trials and proof of concept with major carriers out there. My crystal ball says it's going to happen sooner than later, but I can't make. Whenever I make a prediction, I can only guarantee I'll be wrong. Sure.